Good morning, it's Arturo Lobo, responsible of Arcrea Solar Project, which has been carried out by a small group of engineers and architects to develop a solar heating system with generation of changing aesthetics. This project has received a Research and Development Award and it has currently two worldwide patents pending. At the wall of video, we want to present the main patent in detail, and also the description about some products and several aspects related with the technology. What's aim is illuminate with a sunlight house or a building or absorbing that energy, according to the thermal demand curve and without mobile elements. It means the system absorbs much more energy in winter than in summer, and that is necessary to be able to dimension a solar heating system, which in winter needs 8 times more energy than domestic hot water, that ACS curve, and nothing in summer. In addition, that technology allows generate pictures or colors on the building's facade without additional elements. Those images or colors could change with the sun or spectator position, as well as this system is able to generate high concentration. To understand the system, it is recommended to start by the videos of summary and basis or fundaments. We apologize for the simplicity of these videos, which has been created by the research team itself, only with educational and informative intention. This introduction, with a length of 1.5 minutes, is repeated in all the videos. Generally, the main pattern refers to collect the radiation on an absorbing area. However, other possibility is to redirect the radiation directly inside the house or building, after being reflected on the concentrator. Basically, it's like removing the absorption area, allowing light and radiation to reach the concave reflecting surface, which reflects them through the panel, or lower glazing or the visor that is used. This allows to illuminate or to heat inside according to the seasonal thermal demand curve, that is a lot of winter and little in summer. The concave reflective surface can be optimized according to the different criteria. For example, to create small cavities between crystals, among crystals, that besides discrimination summer-winter. Small chambers formed by between two crystals, greatly reducing the thermal conductivity of the glass. This image, which is sustained by finite element analysis, shows a typical winter situation. In this situation, the radiation goes into by the external cold glass that is of the left side. When the sunlight is reflected, it's redirected by a little window. The absorbed radiation warms the air that is located at the wall cavity, which is created by the concave reflective surface. This air is transferred partly to the internal glass. The air of the chamber stays very stratified and slowed, reducing in this way the thermal conductivity, in addition the wall cavity contribution. If an insulating material is chosen for the blade or contour, an enclosure wall is created, which is named light wall. Furthermore, to provide the differentiated path of the light of summer or winter, it has a thermal conductivity around 1 watt per meter squared per Kelvin degree. The picture shows the speed distribution of the air into the two cavities. As could be seen, speeds that there are at the concave reflexive surface cavity are very low. That situation provides the great insulation of the light wall. The thickness of the wall could be from a few centimeters to 15 to 20, depending on the need, and the cost is even lower as the of some conventional walls. In summer, the most part of the radiation is reflected again to the sky through the exterior glass. Also, the wall cavity of the concentrator gets warmed, just a little of this heat and this radiation passed to inside. The calculation of this concave reflective surface is relatively complex. It could be summarized on the sun being with lower elevation that fall on each point of the concave reflective surface, which reflects toward the nearest of the point 67. Apart from this, the section 77 is not necessarily straight. If it's now required to maximize the insulation, a simplified slat could be used. Furthermore, to get properly discrimination between winter and summer, it allows an ample side to the outside and still keeps giving an important insulation. This slat is very easy to fabricate and it's a simplification for the previous one. It corresponds more or less to its central part, removing the peak. If the geometry and the position of the key point of this configuration are optimized according to the pattern, the concave reflexive surface of this simple slat will be a circumference or an ellipse with a low eccentricity. Even with this, slats could be more simplified, keeping pretty well the characteristics of the path of light and the sun radiation, according to the seasonal thermal demand curve for each locality. Also could seem that this simplification is as easy as being represented. The geometry and the key point optimization is more complex than the one of the hash web, such as a web of a beam. The optimal concave reflexive surface is still being a circumference, that is tangent and extension on a point of the parabola, which the concentrator. This slat sheet or slat without web is really appropriate to both sides for shading and sun screening. This is due to its simplicity and price in addition to its elegance. On the other hand, in addition to the external Venetian blind, this kind of slat sheet could be a Venetian blind which has the capacity of being folded as usual, or could be placed ahead of a trombe wall to make it be heated just which is needed in winter and a little as possible in summer. Slat solutions for vertical walls are applicable to slats for roofs or sloped surfaces. They still meet the requirements about the discriminated paths of light and radiation. Similarly, the slat could have a core and be placed between two crystals. In this way, it's also achieved a really good insulation and cleanliness. And only design could be ready to accomplish these functions of slats, as well as to insert vacuum tubes between the slats and heating water according to the demand curve. The lateral frame will have the holes to install the vacuum tubes when that is the application. An additional characteristic about this configuration is scattering the direct light and redirecting it towards the vertical. With that, it could be creating an ideal roof light, which lets the light pass in winter and provides sunny in summer. In addition, it has a great thermal insulation and illuminates the floor and the inner courtyard in a very uniform way. It is required to the light that passes to render the more vertical. The concave reflexive surface could be lengthened, though this makes complete the slat's design. These slats with the concave reflexive surface lengthened could be also placed within crystals. Slats with a concave reflexive surface lengthened are also applicable to vertical surfaces on vertical glazing, to scatter more light and to redirect it down. The patent protects the other version of the slats, which optimize or solve issues that could have some applications. For example, if this position or slats are used as a sun screening between two floors, sometimes the slats could reflect the light towards the upper floor, although it's shading the lower floor. And this could be solved quite well with a non-reflecting extension at the beginning of the concave reflexive area. This extension has the same slope than the maximum angle that is expected to collect and reaches the horizontal position of the end of concentrator. In other cases, could be interested to extend the concentrator until a point close to the previous one. That makes bigger the performance of the original design of a slat sheets or is slat. Moreover, if an external Venetian with this blade type is created, provides optimum shading to the facade with a low cost, especially if the system is simple blades. In winter, most of the light passes through the external Venetian and impinges against the facade, and the air between both is highly heated, especially if the facade is dark. The increase of this intermediate air temperature may be 10 degrees, and sometimes this increase will be enough to get the air inside the building. When not enough temperature is reached, the hot air can be sucked by a heat pump and the coefficient of performance of the same, the COP, can be increased up to 40%. The result is that this energy harvest costs around 2 cents per kilowatt hour, and the total energy produced by the heat pump may be around 3 cents euro per kilowatt hour. This configuration also allows the partially the heat lost by the building itself, which would also be sucked into the heat pump. And this system of external ventilation with a heat pump can compete with the traditional system of a shaded refreshment, being able to even apply in roofs. The video 9 and the next one show the prototypes and explain how to get benefit of the project. Those benefits could be gotten at individual level or for a company, as well as economic and social environmental benefits. If you want to produce or you are an interested client, we give you more details on free drawings. The project has social and supportive components. Watch the videos about how to work, to collaborate, to translate, and so on, and help us to spread them. Click to see the other videos or go into detail on this one.